Welcome back to my channel. Uh, okay. Today we will be discussing about the very important topic about writing a custom opcode. So some projects will have hundreds of custom opcodes. Some projects even will have thousands. Yeah, there are thousands and thousands of custom opcodes in a big project. So it is critical and important to learn about writing custom opcode uh, for a developer role or a pricing analyst or an administrator or an architect. Everybody should know this custom opcode concept and how to write it, especially for the developers. If you want to become a developer, um, which is the most demanding job, that is Oracle BRM developer, you should know how to write a custom opcode. So this is in C programming, and it will use the PCM libraries of Portland Frontend, and then we will be writing the opcode hands-on in the VM. So be prepared to see the full video, follow each and every tip, each and every line, what I'm saying, and make sure that you do the practice as well, because practice is critical. Practice makes it you know uh, makes you perfect. You may face different errors than I may face. So when we do more practice, we get into more errors, and then you will know how to resolve each and every error. So that's the most important thing here. So remember that most of the work will be about writing custom opcodes, fixing the custom opcodes. In the first introduction video and few other videos, we discussed about the opcodes, what are all the different types of opcodes that Oracle BRM has, and all those things. So if you haven't watched those videos, watch those first and then come back here. So basically, an opcode is nothing but an operational code. It is a function in C. It accepts an input and it will process the data. It will provide an output. So that is about the opcode. I'm not going to discuss more about the opcode because we already discussed in the past video. So let us directly jump into the VM, and let us start preparing the opcode. It may take a little bit of time for me to type, but let's do that. I don't want to uh, do the copy pastes and all those things, rather type by myself each and every line so that you will know what exactly we are trying to do here, step by step. So try to follow each and everything that I'm trying to do here. Let's go to the VM, and within the VM, first thing that we need to do is create a directory. Let's say cd pin home and cd source sys. So we are writing a facility module. Within this facility module, all the facility modules are here in this directory. So you can see here, these are all the facility modules. We can create a custom opcode here in this folder, or we can create in any other folder. So there is no hard and fast rule here where to put the custom opcode. So for simplicity purpose, we are going to create a very simple opcode, and then I'm going to make the logic very simple, pretty simple, so that for the beginners it will be easy to grasp the topic. So I'm going to create a new directory here so that you will get the concepts pretty easy. The most easiest thing is you can open any of these directories and add your custom opcodes. That is also possible. But since we are doing it as a fresh custom opcode from the scratch, I'm going to create a new directory. So I'm going to go to the fm custom op directory, no files here. Let's first create a config file. So a custom opcode requires its own C file, and the shared object that we are going to create should have a config file and a make file. So I will discuss about what is a shared object later on, but first let's focus on creating the code, follow the lines, and I mean follow each and every step that I'm explaining, and then we will discuss about what is shared object and all these things. So you can simply copy any file from any of these folders and then keep modifying it. That's also possible, but let's try to do it from the scratch, not a problem. So first I'm going to create a config file. So let's name it as fm custom op nothing but opcode. So some name, we can give any random name. So it is, so this naming convention says it is a custom opcode. vi is the editor, as you already know. Let's try to put some comments here saying that it is a config file for the custom code. So you know how in C how to put multi-line comment. This is how we do it. Multi-line comment, and then after that if and def. That means if linked is defined, then just put the description of the file like this. So if you already know what is lint, then you don't need to learn again about it. But if you don't know about lint, it's good to know what is lint and all. So it is end if I'm going to end this. So this line, these three lines will be there in almost all the opcodes, custom and policy opcodes and so on. So let's keep it like that, and then we will need to include some of the uh, important header files that we need. Um, so stdio, and then so under ops folder we have customer.h. So before going to here, so uh, we'll discuss about what this custom opcode is going to do. So this custom opcode is going to do a simple search based on the first name. So the input for this custom opcode is going to be the first name of a customer account, and then this opcode is going to search the database and then provide us the results. So that's the custom opcode. In the previous video, we built a search template. So in that search template, we have written the input for the search opcode, and then we observed the results as well. So the same thing today we are going to do in using the custom opcode. So let's try to see what role is. So so stdio is basic. I mean, like the standard C header file that we know, and OPS is the opcodes folder for BRM. I will show you that folder and the header files. So you will come to know slowly and gradually about each and every header file, what is a header file, and what header files does and what it will have. All those things you will be able to open it and see the contents of the header files. So for now, just remember this, and then I'm going to use pin export is nothing but the pin libraries, one of the pin library function. Pin libraries and PCM libraries is what we need to know when we are trying to write custom opcodes, right? So custom op config. Since this is a function, we need to put it like this. So these are all standard way of doing it, and then we need to define a structure. This is also pretty standard, which doesn't change. So config, and then the structure equals to let's put opcode and function name. Okay. Here what we need to put within this structure is that name of the opcode that we are going to write. So let's try to name the opcode as custom op account search. So some name we can put any random name, not a problem. But this naming convention is very important. So the opcode name, the function of the opcode should start with op underscore and then some name. So it should always starts with op underscore. Okay. Comma, and we are writing only one opcode. You can include any number of opcodes here. This is a config file for the custom opcode folder that we have created just some time back, and this file can have even 1,000 or 100, whatever the number of opcodes that you want to write. You can include all of them here. So that's what the config file is about. Okay, so 0, comma, and character pointer 0. So this is the structure that this is a structure. See in you know what is a struct is all about. So this is a array structure with standard name cmfm config, and then the name of the function, config function, and the list of opcodes. So at the end we need to give a character pointer of 0, so which nullifies the structure. And after that you just need to put another function. So this is just for Windows. It is not mandatory to write this code, but let's put it void star and then fm custom, our function name basically, op config underscore fm and see. I will for sure I'll make another video explaining more about each and every keyword that we are typing here, because if I explaining each and everything and then typing it, this video may cross 2 hours or 3 hours. I don't want to make lengthy videos. Rather, I'll make simple and short videos so that you can grab the concept within the short period that you have. So this is the this is the config file. I'm just checking if there are any spelling mistakes and all. Hopefully there are none. Let's save this. So in our folder right now there should be one file. Yes, got it. Now next thing that we need to create is uh, the the opcode, the custom opcode, that we are trying to build. So I'm going to say EIFM custom account search.c. So all the files should start with the name fm underscore. That's important. Those files will be considered. That is the naming convention we must follow. So it should start with fm, but after that we can put some name that we would like to put. Um, so edit it, put the comments, put the comment. Just try to say that. Just try to put the aim of this particular. So let's say put file name fm custom account search.c, and opcode name. We should give a name to the opcode, because we discussed that every opcode uh, is a function in C, and it will have input and output. So we should give a name and a number. We will discuss about the number once we complete this code first. So description, put some description saying that search for a search customer accounts by using first name, for example, something like that. So let's so that's the multi-line comment in C. After that, again, when linked, we need to define the linked. Linked static constant. Next, include all the mandatory files. Include the standard input output. Include standard library. Include string. Include pcm.h. Under ops we have because we are trying to search for the customer related information, it will be under cust.h. Cust is nothing but customer, it is not custom, so that's why we are trying to put everywhere custom instead of cust. because cust is for customer in BRM. So CM underscore FM standard file. You will learn about all these header files going forward. For now, just try to remember that these are all the header files that will have required things. So FM, I think it is called FM details. In case if the file is not found, it will throw error during compilation. So nothing to worry about it right now. If we miss it or if we put wrong name or something like that, then we will definitely get into an error which we can fix later. So nothing to worry about any of the names right now. Later on, once we are done with this, you will be able to see what exactly this header files contains, because you will be able to access these header files within the VM and should be able to see what each header files contain. So export underscore op. Export underscore op is nothing but we are trying to export the opcode through the shared object so that it will be available for the entire BRM application. So export op again is the BRM's implementation implemented keyword. So op underscore custom account search. So it's important to know this naming convention, what we are putting here. So basically op underscore should be there for an opcode, I mean for this function to begin with, and then some name. It can start with some name. So there will be two functions. Each custom opcode should have two functions. One function should start with op underscore. Next function should start with fm underscore. I'll show you that one as well. So let's say cm nap connection. So first cm connection t is the keyword. So let's say this is a pointer. So for every pointer variable, we will put p at the as a suffix. P nothing but pointer. So this is one pointer, and then int opcode is an integer. Next flags. Every opcode will have some flags. If we want to change the behavior of the opcode functionality based on the flag, we can do that as well. Next, pin underscore flist t is a data type that we discussed in the previous video, that to define the list of fields and values, that is called flist in BRM. I underscore flist p stands for input flist pointer. Flist is nothing but field list. That is what you need to remember. Next, pin flist t. This is a double pointer. Return flist is always a double pointer. So that is what you need to remember. Why double pointer is it's all about the memory. So how memory is returned in C programming. If you know that, then you know why it is a double pointer. So you will learn all those for sure. For now, just try to sink in that return list will be a double pointer. So this is the definition of the function, first function. So let us define the next function as well. So you know what is static void basically. So fm. This is a C keyword. Static void is nothing but the C keyword. So if we are if we would like to return any data type, then we can simply use static void and fm custom. So this second function should start with fm underscore and then some name. So first function starts with op underscore, next function should start with fm underscore, Um, so that naming convention should be followed everywhere. So and then later on, next is um, PCM. We need to open a context pointer here in this function, in the second function. So this context pointer is the main uh, important driving factor which connects to the particular database. So in BRM we can maintain multiple schemas. Multi-schema is available from 7.5 onwards. So you can define uh, which one to connect, or we can always say that the schema is defined based on the database number and so on. So pin flist t, written flist is a double pointer, pin error buffer t is ebuff p stands for pointer. Okay, so next let's put the you know opcode name custom op. This is our opcode name, custom op account search void op custom account. If you see the function name here, this is the same function that we defined above. So we first defined the function, now we are writing the code within the function. So map connection t. So these two are standard functions. You should have it. You can have more functions. Let's say you can have 100 functions or 1000 functions if needed. That's not a problem. But these two mandatorily should be there. We are trying to implement a very simple basic one so that it will be easy to grasp, and then later on you can add more and more complexities in it. So flags. After that, input flist and output flist, return flist. I mean, pin flist is the data type for BRM. I underscore flist p. So I underscore flist p means input flist pointer. So we have to pass input flist to this opcode, and then it will process that opcode based on the logic that we write uh, within this opcode, and then it will return the return flist basically. So that is the whole concept. Um, so the same definition, whatever the definition, the parameters, I mean whatever the parameters that we are passing for this function, we should use the same when we are writing the code for the function as well. So this is as per the C standard. Uh, C standard. So now first we need to open a context pointer PCM context T, and then put ctxp for example, which is the context pointer, and then um, cnp. So this context pointer and this connection, it is not trying to connect to the database directly. It is connecting to the DM. So which schema to which DM it has to go and all will be decided by BRM later on, the database number for the account based on the uniqueness and all. For now, we are just talking about the base setup where there is only one schema. So we are trying to connect to the DM. So we discussed in the first video about the architecture of BRM, what is CM, DM, and so on. So it connects to the DM. DM will decide to which database it has to go. So it is context pointer that we are trying to establish to connect to the database. And after that, every function should have this. So check whether there is an error already. So this after once we complete this and compile, I will show you where to check about these uh, PCM libraries, like what is pin underscore err underscore is underscore err does. So what is implemented already in that library and why we need to use it, how to use it, where to use it, all those things we will see. But for now, just remember that we need to do an error check every time when we write a function at the beginning like this. And then so try to dice little by little, and then you will be able to learn each and everything. So first, our return f list is r underscore f list p. We don't want to have any data in it before we start the function itself. So the first thing that we need to do is a sanity check. It is good to put always the comments, multi-line comments about each and everything that we are trying to do. So here we are trying to do sanity check of the opcode. So, so go here and if so the first sanity check that we need to perform is, this is mandatory, this will be there in all the opcodes. If opcode not equals to the one that we are like custom op account search, if this is not the thing, then we need to throw an error, because this code file, this function expects the opcode name should match with this particular name. So it is like it is mandatory to have the same name you should use everywhere when you are when you want to use this opcode, because an opcode is a function in C, as we discussed earlier. So the names are crucial. If you don't use the name correctly, BRM will throw an error. So you need to put all this. You need to know what is pin underscore set underscore error and all. Pin error class system determinate. So we in the previous video we discussed about the error types, like within the, when BRM prints an error in the log, what are all the things there will be in that error, how to read the error basically, how to understand that error, what exactly, I mean the contents of the error, how to decode the contents of the error, and how to grasp it, or how to know about the error, how to diagnose or understand more about why it is happening, where the error is coming from, and all those things we have discussed. So it's good to know first all those before watching this, but there is no problem. What we are writing here are the standard ones. That means you can just copy paste every time when you are writing a new opcode, simply these lines, because these are all these will be repeated all the time. So op custom account search sanity check error. put some meaningful name so that when there is an error, you will know like why there is an error and all those things. So then, after that, so if there is an error, it's simply we need to return. So that's the return keyword will be used everywhere. Uh, so now I'm not putting a lot of comments here, but it is good to put comments whenever there is some new functionality that you are trying to implement. So this pin error log f list is nothing but is a macro, or it's a function. It's a part of the library of BRM. It will print the f list that we want to see in the CM log. So uh, as you already know, there are 3 log levels for BRM: error, debug, and warning. So error is the lowest, value is 1, warning is 2, debug is 3. So we don't want to print all these logs when the log level is set to error, because uh, what happens is in production we don't want to print so much in the log. That's why we will keep the log level in production as error. So all these values will not be printed, so that log will not be grown too much heavily. So in production we just keep error level only. If it is a development or test instance, we will enable that log level to see what exactly is happening within the code, and if we want to debug something, if there are any errors, then definitely this debug log level is needed in the development instance. So our function name that I have mentioned above, we are calling that function here. So now you might understand why we have defined 2 functions above. So these 2 are mandatory functions, and this function is called here. I mean the main function is called here. So main function can have any number of functions. So what the all the functions that you are going to write within this main function, which is like fm underscore custom account search, all these functions will be executed. So that is the key thing that you need to know. Pin error, again, if you see this, we have written the same above. So whenever we call a function, we need to have this, we need to write this basically. So pin err log ebuff. If we want to print the error buffer, this is the macro that is provided by BRM. So we don't need to write each and everything from scratch, but the key thing is that we should be able to, like, remember and then utilize these macros wisely whenever we need to use it. So it is all about knowing the macros. It is not 100% about the C programming. C programming is just the basic that you need to know, like pointers, single pointer, double pointers, and those things. But rest all is about the BRMs, uh, out of the box macros and libraries and all those things, header files, etc. So let's say if there is no error, then what we need to do is uh, just print the f list, saying that this is the f list that I received as part of the input. So we need to check the input f list as well, because we need to check, you need to be able to see in the log what F list is passed. Let's say we are expecting some mandatory fields in an F list, and if there is are not there, then you will be able to see in the log and say that okay, these mandatory fields are not passed. So we are trying to, what we are trying to do is, if there is an error, then just print the error buffer, otherwise just print the uh, output F list. Yeah, so we have done that, and then finally need to return, and let me delete the empty lines. So indentation is very important. Always keep the indentation for readability purposes, because C programs grows up to thousands and thousands and thousands of lines. So it is critical to keep the indentation for the purpose of readability. So this is now the second function. So which is the main, which does the work. So the first function is just copy paste. You can just take it and then copy and paste it and change the opcode name. That will make that function ready. Second function is the one that does the actual thing. So as we discussed, the aim of this function is it is going to accept first name as the input. It is going to search the database, find the details, and then it is going to produce the output. If it finds the results in the database, it is going to print the results. So that's the functionality that we are going to implement in this function. So now return of list and error buffer. So if you see this, if you see the code that we have done so far, you might have observed that everywhere there is a context pointer, there is an error buffer for sure, and input and output is mandatory anyway. So there can be more parameters as well. It is not that there should be only these 4 parameters. There can be more, as many number of parameters as you need. We can define those. So in C there is no limit that you should the function should have only 2 or 3 parameters. We can add as many as we need. So here I am trying to just so what we are trying to do is, in this we need to build a search template, and then we need to perform the search and then print the results. So that is what we are going to do. So for that we need an input F list. So this is an input F list. So it should be capital because it's a C program, right? So now we will see what are all the variables that we need to define. So we will come and define here later. So let me build the search here. So if you know, like if you want to see what exactly is the search, uh, we we have built a search template in the past, and we have executed it as well. So for example, go here, test SLRT. Sorry. Okay, go to test. So this is the search template that we have built, and then yeah, so the same search template we are going to uh, prepare it in the code. So this is what we are doing in this. So as I said before, we just need to make sure we have to do an error check. Pin error is error. So by the time the code enters into this function, then what we are trying to do, if there is an error, simply written, don't do anything, written, because when there are errors we should not perform anything. And clear error, we want to keep the buffer clear every time we start a function. So next, simply uh, validate the input fields. So we only have one field, that means first name. Let's say first name is pin f list. Pin f list field get is the macro, or is the library that we need to use. Our input f list is I underscore f list p that we used above, and then the first name will be pin field first name comma 1 comma error buffer. So this macro expects 4 arguments. Here the input flist are the flist name and the argument name, and one means not mandatory, 0 means mandatory. That means if this variable is not present in this flist, then it will throw error if we use 0 here. And then finally error buffer. So we are taking this value into the first name p. So when we use field underscore get, we are not going to take the memory, we are just going to use the read-only value. So that means this value, we should use it only for the read-only purposes. Otherwise there will be memory leaks. In other videos we will discuss about what are the memory leaks, how to identify, how to do the memory management and all those things. But this video I want to just keep it simple and short, only meant for writing a custom opcode. That's it. Um, so so what I'm trying to do here is, let's say if this first name is null, then I want to throw the error, because this this parameter is mandatory for us. If there is no first name, then there is nothing that we can check. So simply go to a cleanup section. We will define a cleanup section at the end, because we have to clean up the memory when there are errors. So otherwise there will be memory leaks, as I said before. So first let us build the search template. Pin flist create error buffer. So pinf list will allocate the memory for this search input f list. S stands for search. I mean, just any name you can provide, but simply I put like that. We need to put a pointer, db, let's say database pointer, database pointer. That's what it stands for. So we need to use this macro called pinpoint create one comma search -1 error buffer. So this is the pinpoint creates the point. So see, pinpoint create will allocate memory. So that's why we need to do pinf list field put put will assign the memory. It will hand over the memory ownership back to the F list. So when you are writing code within BRM, it is very important to know about the memory management. There are four things: pin F list field get, pin F list field set, pin F list field put, and sorry, pin F list field take. So if we know what these things does, how memory is managed by these four macros, then you can write any kind of program within Oracle BRM. Otherwise, the functionality will work. That means functionally the code will work, but it will leak the memory and there will be a memory ceiling of 2 GB. When that memory ceiling limit hits, the program crashes. That means the data will be lost, some of the data will not be function. I mean some of the code will work, some of it will not work. So there will be so much of confusion. In C programming, this is the thing that we need to manage the memory. In Java and all, Java program will manage the memory by itself, uh, called garbage collection and all. But here we need to make sure, we need to explicitly define to which variable to allocate the memory, and then we need to clean up that memory. So it is our responsibility to keep the memory management properly within the program. If we don't do it, then there will be errors, but not related to the functionality. Functionality may work depending upon the severity of the memory leak, but the program will crash. That's the very important thing that we need to remember related to the custom opcode within BRM. Next, pinf list, we have set the flags. We need to set the template. So these are all the standard fields, you know, that we have discussed in the past when we try to build a search template like this. So first we built this search point. Now we have added the flags. Next we are trying to add the template. So this template will come here, and then input f list name. After that, pin field template. Let's say search template pointer and error buffer. After this, we need to build the arguments. So here, if you see, we have built the search point, flags, then the template. Now what left is the arguments. This argument we need to pass, and I mean we need to pass this one as well. We need to build those arguments. So for that, what we need to do is use another name called args. Let's say args flist p, uh, and then pin flist elim add pin field args one comma error buffer. Now we need to add one more f list here, because the reason why we need to do is that there is the field is not there directly under one array. There is an array, and then within that array there is one more array, and after that there is this first name. So there are multiple arrays, array within an array. So we need to have another f list called, let's say, name f list because the name info is the array name. So just trying to put it here, fpin flist lim add. We need to add this to the arguments, because if you see here, go back to the this name info array is under arguments array. So that's why I'm adding name flist p under args underscore flist p variable, and pin field name info at the 0 level. So at the end of this video, I will show you the documentation where to see the documentation for these macros, what arguments it accepts, what argument should be there, and all those things, so that it will be easy for you to refer to the document as well when you are trying to write something new code. So for the name pin field name info array, we need to add the actual argument, which is the first name, because based on the first name we are going to do the search, which is the mandatory parameter. So pin list field set, we need to add this to the name info array, because as you can see here, the name info array is at the level 1, and first name, which is the main argument, is at the second level. That means this first name is under name info array. So based on this number that you can see at the beginning, based on that we can say under which array element the fields are there. So that's the thing that we need to always remember. So the name of the field is pin field first underscore name. So let's say first name p is the one that we have used the variable name above. Error buffer, define the error buffer. And now we need to build the results. So you can add some comments in the C. Comments, you can add multi-line comments, like building the search arguments, building the flist, something like that, which is meaningful. So let's put results flist as results underscore flist pointer. Again, this is an array, so pin flist lim add. So there are two things in BRM. One is the array and another is the substruct. So if it is substruct, it will be pin flist substruct underscore add. If it is array, it will be pin underscore flist underscore lim underscore add. So we are adding the element now. S underscore flist p. I think I put S underscore iflist p at the above. So we are going to add pin field results pin lim id any. So pin lim id any means any number of any array, because an array can have so many array 0 1 2 3, I mean the array elements, right? So there can be any number of array elements. So that's why we are trying to say any array element, you can just bring it and fetch. So now we are done with building the search template. Well done. So now what we are going to do, we are going to print what we have built, because while debugging, it's very critical to see what exactly the flist search template or search flist that we have built, and whether it is properly formed or not. If it is not properly formed, the results will not be correct. So that's why. So the macro to print the flist, which we already discussed, is pin error log flist. At the debug level, we are going to print this, because we don't want to print all these information in production environment. So just simply add fn custom account search, custom account search input flist. The name of the variable is underscore flist p. Next, we need to execute the opcode. So the macro to execute the opcode is pcm underscore op. So we need to pass the context pointer. That means it connects to the database, and then it calls the out of the box opcode. So we discussed about out of the box opcodes, nothing but base opcodes, system opcodes. So these two are, so PCMOP search is the system opcode. So we need to pass the input flist for this, and then return flist. Return flist, let's call it as return underscore output. So return underscore output flist p, and error buffer. Now, after executing a function, as we discussed earlier, we always need to check the error buffer. So if pin error is error, if there is any error in the buffer, then pin underscore flist underscore destroy underscore ex. So at the top we have written like pin flist create like this. This will allocate the memory. So in C you might know already which function does the memory allocation, like calloc, malloc, all those functions. So the same thing is used within this macro. You will not be able to see the source code for the out of the box macros and all, but we will know what is the definition of it from the documentation. So that much we need to remember. So when we say destroy, what we are trying to do is we are trying to deallocate or release the memory that has been allocated earlier. So programmatically, we are allocating the memory. At the same time, we are deallocating the memory or releasing the memory as well. So it is developer's responsibility to keep the code leak free. Leak free means there should not be any memory leaks. So if you allocate the memory and if you don't release it, then there will be memory leak, right? And then once the memory ceiling get hit, then the program get crashes. So that's the specialty about C programs that you should always remember. So I'm just trying to print the return flist, because once we execute the opcode successfully, the search opcode successfully, using the input flist that we have built, we are just trying to print the output, the results that we got. So that's about it. Pin flist destroy ex. So why we need to write within C and all these things is because BRM is built on the mainly on the C programming, because C gets executed so fast, so quick. When there are millions and millions and millions of transactions coming in, then the C programs gets executed so quickly and so fast. So that's why you will not see any main function within this function, because there is a shared object concept. I will explain it in a bit. So there won't be any main function here. Once we start the program, all these shared objects will get uh, will get uh, will get into the memory of the connection manager. So I think let's try to put something called error code somewhere. or we can use that. So let's try to use some variable called error code. Error code. It is not mandatory. We can still use the pin error is error or not, but just trying to show you a different method as well. Pin flist destroy ex. Let us destroy the input. That means we are deallocating the memory. That's it. That is the meaning of destroy. Pin flist destroy the output as well. In case if there are errors. If there are no errors, we don't want to destroy it. We simply want to return it, return the value of the return, the return f list back to the function. So here, else, that means if there are no errors, then what we need to do is the double pointer, pass the return f list to the double pointer. That's it. That's the thing that we need to do. Okay. So after this we need to like to have the Makefile, but before the Makefile I think I forgot to do one more thing here. We need to define all the variables that we have utilized before below. Let me see the flags and all those things. So YY and P will copy and paste the line in uh, in Unix. So remember that so that it will be easy to copy and paste. So I did again YY and then P. So it is, let's say we need arguments f list. After that name f list and then results f list. After that we need to have point underscore t, that is for the search database point, search underscore db nothing but database, pdp nothing but point pointer. So next flags, we need to define flags yes, underscore yes, flags. We discussed about what is flags 512 and what are all the other flag values that we can have for a search. So refer to the previous video and the documentation as well. Let's use this error code 0 and let's try to define the first name because we are this is our only input for this simple opcode, and then let's say yes underscore template pointer. So here we need to put what is our search templates query basically. I will just copy from here and then paste here. This is our search template. Now we got all the variables. Let me check one more time. Error code, let's try to put if first name is null. Then let's try to put this error code as 1, so that if error code is set, then at the end what we are trying to do here is, if error code not equals to 0, then we are simply destroying everything and then not doing anything else. So we got the opcode as well. We have built the mandatory two functions are there. We built the search template. We are trying to print the results after doing a search. So we got the two files. The other file that we need is the Makefile. I'm not going to type the Makefile from scratch. I'm simply going to get it from another folder, let's say fmapn pol / makefile to here. And then I'll modify it, because it is not really mandatory for you to type each and every line in the Makefile. Simply, you can do this for the opcode as well, but since it will be the very first video, I typed. So all these lines will not be changed. What will be changed is that let's say here, instead of APN, let's put customer.h, and here this is the important place. So here what we need to do is that put the name of the C file that we have prepared. So the name of the C file is fm custom account search.c and the config file. So both these files must be there, must be under this. So let's remove all other. Let's remove this. Then change the config name as well. fm custom op config. So that's the name of the config. So do the same thing for the objects as well. So as you know, when we compile a C program, it will create an object file with the same name .o. .o is the extension. So here try to put fm cust config.o and remove all other files and change the last one to fm custom account search.o. O is the output. Similarly here you can just put any name for the library file. Custom op stands for opcode. So that's what we are trying to do here. So the remaining lines we don't need to change. These are all you know these are all standards. So we just put the files that we need to prepare here, and we are trying to this is going to compile the all the files basically. Okay, next, let's save this. We got all the mandatory files that we need. So before we compile it, we need to define the opcode as well. So that is, go to cd pin home directory /include. So I'm going to use an existing file. You can create a custom file as well to include our custom opcodes in a different file, but for since you need to know about this file, it's important to know, so I'm trying to put it here. So what we are trying to do here is that see, look at here, 0 to 9999, so almost 10,000 till 10,000 it will be used by out of the box BRM. So BRM reserved these numbers. We should not use a number between 0 and 9999 for our custom opcode. So before going to that, I need to tell that whenever we define a custom opcode, we need to define a number for it. We need to assign a number for it because an opcode is a function in C, and we need to have a number for the function. So we can use the number or the name of the function, name of the opcode within the code. So we should not use these numbers. So the customer use from 10,000 to almost 1 million. We can use any number within this. Again, from 1 million to 10 or 10 million to some million, or 1 million to some number, again is for BRM. After that, again it is for customer use. So I will try to use a number within this range, which is between 10,000 and 1 million. So let's go back to the end of the file. So as you can see, the custom opcodes are defined like this: hash define, name, and then number. So before end if, we will just try to put saying that custom opcodes, right? And then end the comment. So here I'm going to put the same way hash define and our opcode name custom, the same name that we used in the config file. If you remember, when I prepared config file, I used this name. So let's say we will use 12,000. Okay, so after this I'm going to say end of custom words. Okay. I'm going to delete these empty lines and save this. Now go back to the our folder, get these files. now 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 the time comes to compile. So compilation is done using the Makefile. Make clean. Make clean means it will remove those object files if there are any, and then it will create the fresh object files. And then make all or make build, whatever, we can use anything. Simply make all will be sufficient. Make all will do everything, but just to make sure, I'm trying to do the cleanup, and then let's see if we get into any error or if it gets there are so many errors. Okay, let me see what all these errors. So there will be errors. Be prepared to see errors, and then we need to figure out, we need to fix those errors. There could be some typos and all those things. So let's see. Pin error log undeclared. Maybe we are missing some maybe we are missing something. Let's come from the beginning. So in file 15 unterminated if and def. Okay, unterminated if and okay. Let's try to look at line this, line 22. So when you are when you resolve so many errors, you will gain so much of experience. So that's the key here. So be patient here with me while I'm trying to fix all these issues. Uh, Static constant. Okay, I didn't define the static constant character. It is character variable, and else, and then I did end if. That may resolve some issues. Let's try to compile it again. I will clear this so that you can see again all the errors fresh. Okay, this time little less errors. Again, I am seeing unterminated if and okay, okay, from this one. Let's see if there is anything in this code. Line number 14. Include. Let me say static char. If and def lint static char syscsid equals to $id, and if is there standard IO dot h ops cust dot h pcm dot h. Why it is saying struct. Okay, struct and then custom op account search. Okay, op custom account search 0. Is there any typos here? I don't see. Okay, if and def. Okay, okay, got it. Okay, here there is a. So that's why we need to be little bit patient when we are trying to code BRM. So a small typo can create so many errors, and then we have to go line by line. Just imagine if there are 1,000 or 2,000 lines in this code, and then you need to go through line by line. So it requires a lot of patience for sure. So based on once you get the experience, you will be directly able to hit the target, hit the go to the error and then resolve it. But till then, you should be able to do it like very carefully. Okay, somewhere I put. Let's try to resolve those. Okay, somewhere I put P capital for pin error buffer. Let's try to fix that first. So fm account search dot c, copy, go to line number 93, 94, 93. Okay, here I put capital P. It is case sensitive, so we should always use the case very carefully. And then I saw somewhere around 90, 38. What is 38? Okay, it's talking about the same definition. So let's try to compile again. You can compile as many times as you would like to, as you wish. So there is no problem doing that. PCM ops dot. Why it says undeclared pin error log fm undeclared first use in this function. Let's try to look at this. It will resolve few issues. So go to the file again, go to line number 65. If opcode not equals to custom op account search, all looks good, there is no typo, but pin set error buffer pointer pin error. Okay, that's the thing. There should be an underscore, pin underscore, and then pin error class system determinate. Small typo can make your life difficult, so just try to always mindful of typing the typing the lines with proper indentation as well as case, as well as no spelling mistakes. So let's again clear this and then compile. Let's see how many errors this time. Why it is still talking about unterminated if and def. Line number 14, and after that again in unterminated if and def here, line number 15. So those are all the two issues, and after that there won't be any other issues. There is again 127 assignment makes pointer from integer without a cast. So let's try to look at this one first. So go to the account search, line number 127. Args flist. What we are trying to do in args flist is that pin flist. Oops, sorry, there is a typo. Pin flist lm add. Okay, let's try again. Okay, so now our errors are only related to the unterminated if and def. So let's look at both the files uh, and then try to fix those issues. Line number 14, include, let's see, if and def, if and def lint static character SSES ID equals to, okay, looks good. Okay, there is an end if here. Include, is there any spelling mistake? Include stdio, include ops cust.h, pcm.h, cmfm.h, fm custom op config, struct fm config, fm custom op config equals to this. Let's try to see if it got entered correctly. Shift 5, you can use Shift 5 to go back and forth. Okay, this looks good. Custom OP account search, opcode name and the function name. 0 char star 0. If and def ms. Okay, if def, sorry, it is not if and def. If def and then yeah, that should resolve our issue. Okay. Still not. Let's try to look at this one. If and def lint sim.h include yes cus.h and if hash include. Let me try to see if I have missed anything in the make itself. Okay, make file OS pin version pin directory include directory and then included files. Maybe files are fm custom op config and then fm custom account search. Same thing goes here, fm custom config and then library path fm custom op dot extension lint cpp flags files um, objects libavian objects. Okay. And terminated if and def. stdio stdlib string pcm. The included directory is 3 directories back and then include. So yeah, 1, 2, 3 and then include, yeah, that is correct. Why it is complaining about and if to remove this. Let's see. We'll put it again later. Okay, I got it now. Okay, okay. I got it. Okay. CD. VI PCM ops.h. We haven't properly terminated this stupid thing caused these issues for us. Okay. Let's go back. Pin home. Source sys fm custom op. Let's add that one back. What we need to do is, if not defined lint static constant. You know what static is, constant is, character is in C. So these are all C related stuff. So you already know about it. Name of the file fm custom account search.c. That's it. And then end this. And if now try again compiling. Let me clear this. We are again compiling all the files that we have modified so far. There is still one error. fm custom config.o, no such file or directory. Fm custom config.o. Oh, okay. It's fm custom op config. Okay, we need to make some change here. Fm custom op config. Okay, yeah. In the file name, I put it correctly here. You can see, but when it comes to the object, I didn't. There is a typo. So all these things, it's good to do mistakes because from mistakes we learn a lot. So again, let's try to do the skipping incompatible. Just ignore it. That's okay. Let's try to see whether our shared object got created or not. Yes, the SO file is the shared object, and it should be there in the under the library as well. Let's try to do a restart of the CM, and then we will test it out. CM dollar stop underscore CM is the command to stop the CM. CM is the connection manager. So basically we have, I think we haven't done one more step. Let's try to do that. once the CM gets stopped, we'll try to do that step first. So in case if you feel that the video is lengthy, you can just uh, fast forward it. You can skip all that research that I have done to fix the error and then come to this portion. Okay, so what we need to do is, let's go to this sys folder, cm vi pin.conf. So this pin.conf is the configuration file for the connection manager, and it will consider like, you know, for example, it will consider the shared objects that we create from here. So let's go to the another example. Yeah, you can see here. So what happens is, in theory, what happens is, whenever we create a custom opcode, when we create a shared object and so on, so what will happen is, when CM gets started, when we start the CM process, CM is the connection manager. When we start the connection manager, it will read its configuration file. It will consider all these shared objects and keeps it in its shared memory. So, so CM will keep all the business logic in its memory. How it will does based on this shared object. You can go to Google and do a search to see what is a shared object in C. So when we create a shared object, when the CM process starts, it will keep all its information in the memory. That is why the processes in BRM is super fast. It doesn't look at, it is not it. It is not a, it is not like Python is like interpreter language, right? So it reads line by line and then it executes, but here that is not the case. All the business logic is defined in the shared objects, and that shared objects are stored in the memory, are kept in the memory, like the random access memory of the CM. So it can take their decisions instantly. It doesn't compile the code every time when we try to do some, like, you know, business functionality check. So for example, we are trying to do something, then it has to go through the code, it has to compile the code, and then it doesn't do all this. So it simply looks at the uh, random access memory, tries to check whether it is following the logic or not, and then it executes the opcode. So that's what it is. So let us try to link our custom opcode also here, so that when we start the CM, it will read our information. It will read the shared object of our custom opcode and keeps it in its uh, memory, runtime memory. So pin home, the same way I'm looking at the above line and typing it. Library, our library is fm custom op dollar library extension, library extension, and then config name of the config. So that is fm custom op underscore config. If you remember, we have defined the config or config function name like fm custom op config. So the same name we need to provide and then save this file. So in another video, I will explain all the configuration parameters of the connection manager. If you see here, it is more than 3,300 lines. So it is a huge configuration. It is important to learn about some of the important parameters of this configuration, which I will cover in next video. So let's go back to the test. Now we stopped the CM process a minute ago. Okay, it is not running. Let me start the CM. It's getting started. check whether CM is up or not by using testnap utility. We discussed about the testnap utility in the previous videos. Okay, it is working fine. Um, so we need to prepare a file like this. Let me. I have prepared this already, so you can see the contents of this file. So basically the 12,000 is our opcode number. We can use the name as well here. So we can put the name and then execute it. So what we are trying to do is we build the F list. Basically we pass the name, we are passing the name as an input parameter to the opcode 12,000. If you remember PCM ops.h, we put the opcode number as 12,000 for our opcode. And now I'm going to execute this file. So basically when we do this, what happens is it is going to execute the custom opcode that we have written. So let me go back to CM, clear the log so that I can show you what it has actually executed. Uh, so go here, test snap, paste it. We got the result of George as the first name, and go back to this log of the CM, and then here search for our FM custom OP underscore account, custom underscore OP. Okay, since we are using testnap, it didn't print here, but yeah, it will print the the input F list and output F list. Um, so input F list here, if you can see, input F list is the first name, and it printed all the log here. So yeah, if you see here, it printed the input F list. It printed, actually, my mistake. I didn't check this properly earlier. So it printed the input F list. So this is our custom opcode, OP custom account search input F list, charge, and then it printed the output F list as well. So that's how we need to read the CM pin log. So that's about it for today. We'll explain more about the different macros and all those things. So if you want to look at the out of the box documentation, go to Google, search Oracle BRM 12 writing custom facilities module, and look at this 13th chapter here. So this is 12.0 version, so you can go through this entire document to read and go through what exactly is about custom facilities module in BRM, how the C code looks like, and all those things. All right, see you in next video. Thank you so much. Do some practice, and always enhance your skills by doing more and more practice. Thank you so much.